Hi, I'm an old guy and I do maths, and today I thought we might have a look at what exactly constitutes a line of best fit. I'm not going to get into the nuts and bolts of how you calculate such a line because there are a number of ways of doing that. They range from just casting your eye along the collection of data points and drawing a line that you think fits best, all the way up to calculations, which are usually done on a calculator, that give you a thing called a least squares regression line. Now, I should also mention that the line of best fit is probably one of the first things that you discuss when you get into linear regression. And again, I will explain linear regression in another video, but to put it very simply, it is a way of trying to find a mathematical formula which best explains a scatter plot. And that is what we have here. We have a scatter plot. And by the time you get to discussing lines of best fit, you should be familiar with the idea of what a scatter plot is. Now, a line of best fit, as I said, can be found in a number of ways. And what I'm going to do here is I'm going to attempt to draw a line of best fit. How successfully I do that, well, you can be the judge of that. But there's my line of best fit. And you'll see that I've got a number of data points below it and a number of data points above it. I'm not saying that this is perfect, but it is my attempt using what's known as line of best fit by eye, or using the iometer, as one of my maths teachers used to say, just taking a look at the thing and saying to oneself, well, where would a line fit here, and how would it fit best? And that's what I've attempted to do. Now, what does the line of best fit do? Well, as I said earlier, it's a mathematical attempt to explain the pattern of data that we have here. And if you ignore the line for a moment, what you see is that this data is roughly positive in its trend. And if we then institute the line, you can see that the data sort of clusters around a line like this. It could be a little bit further up here, it could be a little bit further down here. I'm not saying that it's perfect. What the line of best fit does is eventually it gives us an equation in the form of y equals mx plus c, or y equals a plus bx, whichever one of those you choose, with which we can make predictions about data that is either within this data set or further out here. So it allows us to say, for instance, what we would expect if our x value were this, or if it were, where's there a gap? If it were this, see, we have no data here. We've got data here and data here. But if we were going to try and predict what the data should be, it should be somewhere around here if we were to take this x value. Now, that's really all there is to it. The line of best fit is a line, just to repeat myself, is a line which is designed to give you a way of explaining how this data is grouped and the direction that it's heading in. So in this case, we've got a positive gradient, and we've got a y-intercept, so we've got a value at 0, and what you can see is that basically the line has this data clustered around it. What is not a line of best fit would be something like this. That doesn't help anyone. The line of best fit must obey the trend of the data. How good that fit is, or how good that line is at predicting what, for instance, a value we don't know will be, is the subject of another video, and that comes down to things like correlation coefficients, Pearson's correlation coefficient, which you sometimes hear called R, and of course R squared. But those are subjects for another video. Thank you very much for watching this. I hope you now understand what a line of best fit is. Don't worry about how it's calculated, because, as I said, there are many, many ways, all the way from what I just did, which is looking at it, all the way up to least squares regression line, and those will be dealt with in other videos. Thanks for watching. If you found this useful, please subscribe. See you next time. Bye.